All right, good morning. Just some things to start off with. We'll be looking into the exercises regarding equations in two variables. And but before we get started with this, I want to go ahead and look at the determination of both x and y intercepts, and just sort of a mini lesson to sort of start things off. And we have for x and y intercepts, okay, and we have by definition, okay, for what we have among the intercepts, okay, so we have with the definitions here. So we have for the x-intercepts, okay, so we have an x-intercept is going to have the general coordinates x0, and by definition, okay, this is going to be the location where the graph may be a function or it might be a non-function. But again, each x-intercept is going to be a location where the graph crosses or touches the x-axis. And for what we have in this particular case, so we have again the general coordinates. We have x0, and now for an equation, okay, what you're going to be looking at is in the determination of each x-intercept. So we're looking at setting y equal to 0 and solving for x. Okay, just keep in mind all ordered pairs are of the form xy. So in this case, your y value is at 0. And for what we have in the case of the y-intercepts, and there will be a little bit of inversion of the language, and we have, by definition, the y-intercept is going to be the location where the graph crosses or touches the y-axis. And once again, we have for each point, okay, the ordered pair will be of the form xy. So we have for the y-intercept, okay, we have that x is set to 0. And so for what we're going to have here, is that now for each y-intercept, so you're looking at determining the missing y value or values. Okay, so here we're looking at setting x equal to 0 and solving for y. And just as samples of what we have here, okay, if we're looking at determining both the x and the y intercepts, and we'll start off with a linear function first. And we have, okay, for the first case, all right, we're going to have 2x plus 4y is equal to 12. And just taking what we have in the determination of the intercepts. So again, we have for each x-intercept, we have the general coordinates at x0. Okay. So again, we're looking at solving for x as y is set to 0. Okay, so again, we're looking at setting y equal to 0 and solving for x and utilizing this equation. Okay. So you have 2 times x. And again, just to sort of highlight, just like I had in blue in terms of the operational procedures when initiating. Okay, so y is set to 0. And for this statement, okay, so if 4y goes to 0, we have 2x is equal to 12. And we have with division by 2, we have that x is equal to 6. And with x determined, it follows that the ordered pair for this x-intercept will be 6, 0. As for the case that we have for the y-intercept, once again, the general coordinates we have at 0y, and using the same equation, okay, this time we are setting x to 0 and solving for y. So you have a trading of places in terms of what to solve for and what to set equal to 0. So you have 2 times 0 is 0, and we have plus 4y, which leaves us with 4y, which we have set equal to 12. And we have with division by 4, okay, we had that y is equal to 3. And with the attainment of the y value, we have that the y-intercept will be at 0, 3. And looking at what we have from a visual perspective. And doing a bit of a quick sketch. Again, so we have with the x and the y-intercepts. So we have with our points, okay, so we have the y-intercept, okay, have on the y-axis, okay, at 0, 3. X-intercept we have on the x-axis at 6, 0. And for the line that is passing through both of these points, and this line again is going to represent all the combinations of x and y. Not only those 2 points, but everything else through which the line passes. You have the representation of everything in x and y such that 2x plus 4y is equal to 12. And once again, this is going to be a function, because if you were to apply the vertical line test, you have at most 1 point, okay, as you have a vertical line to intersect the line for all x values. Now, for what we have in the case of a non-function, if we have, let's say, the determination of the intercepts for x squared plus y squared is equal to 16. And again, we have in the initial process, again, so for the x-intercepts, we have the general coordinates at x, 0. Okay, so again, we're looking at solving for x as y is set to 0. Okay. And again, 0 squared goes to 0. And we have left over, we have x squared is equal to 16. And as we go from x squared to x, we can apply the square root property of equality. So we have x is equal to plus or minus the square root of 16. And let me mention now, again, we have a quadratic equation. And you could have moved the 16 over and have x squared minus 16 equal to 0 to establish the standard form. And then you could have factored x plus 4, x minus 4, and utilize the zero product property. Okay, but here, with the square root property of equality, we have the same results, whereupon we have x is equal to plus or minus 4. And so we have, with the values of x attained, we have two x-intercepts. Where we have it 4, 0 as well as negative 4, 0. And for what we have in the case of the y-intercepts, again, we have a changing of hands in terms of what to set to 0 and what to solve for. So this time, okay, so we have with x at 0. So 0 squared plus y squared is equal to 16. And again, just like what we have for x squared, okay, we have y squared is equal to 16. And for the follow through, okay, again, we can apply the square root property of equality. So as we go from y squared to y, we have equal to plus or minus, okay, the square root of 16. And we have that y is equal to plus or minus 4. And so we have with the y-intercepts, so we have 0, 4 as well as 0, negative 4. And just providing a visual once again. Okay, so we have okay, so for what we have in the case of x squared plus y squared is equal to 16. Okay, now we're going to have, for this particular equation, this is going to represent a circle that is going to be centered at the origin and whose radius is going to be at 4. And once again, we have two x-intercepts, two y-intercepts. So again, we have with the x-intercepts, we have 4, 0, as well as negative 4, 0. And for the y-intercepts, okay, so we have 0, 4, and 0, negative 4. And again, now, a circle does involve a lot of operations in both algebra and geometry, thus trigonometry. But however, okay, now a circle is not a function, again, because if you were to have like at the same x value and were to run a vertical line through the circle, you would have the intersection at 2 points for many, many values of x. Right, so a circle again is not a function. But now if you had a semicircle, it'd be like if you had the upper half or the lower half alone, that you would end up with a function. All right, and functions, again, we'll be looking at several times over, repeatedly. And now, for what we have, just going back to the setup and writing up the variations of the equations of lines in two variables. And we have, just going back to what we have on page 176, and we have in the group so we have for number 6, now we're looking at determining the slope-intercept equation of a line that's going to have the following features. Okay, first of all, we have a point through which the line is going to pass. And that point is going to consist of the coordinates 4 and -6. And the slope is provided, whereupon we have the m is equal to 3. Right. And looking at setting up the equation of the line, and we can go through the point slope algorithm. Okay, and again, that formula, we have y minus y01 is equal to the slope m times the quantity of x minus x01. Again, so x01 is at 4, y01 we have at -6, and we have the slope m equal to 3. So we have all the tools necessary to go ahead and substitute. So we have here, y minus -6 is equal to the slope m, okay, which we have at 3, and we have times the quantity of x minus 4. And just clearing up the subtraction of -6, so we have y plus 6. And we have equal to 3 times, okay, the quantity of x minus 4. Now I could have gone ahead and distributed 3 over x minus 4, but I just wanted to sort of pause and mention that within this framework, okay, we have at this step, okay, you're going to have the write-up of the point slope equation. Now for expressing in terms of the slope-intercept, so we're going to isolate y. And right now we have y plus 6, and distributing 3 over the binomial x minus 4. Okay, so we're going to have 3x minus 12. And in isolating y, so if I take 6 away from both sides, so we have y is equal to 3x, and -12 minus 6, this will come out to -18. So we're going to have here, okay, the slope-intercept equation. And you can always go back and check the result. Okay. All right, so you had the slope at 3. And again, for the slope-intercept equation, whatever is alongside x, that number is going to be the slope. And to see if 4, -6 belongs to the line represented by y is equal to 3x minus 18, we can substitute -6 for y. So the left-hand side of the equation is going to be -6. And we want 3x minus 18 to also be -6. So with x at 4, 3 times 4 is 12. 12 minus 18, also -6. So we do have consistency. Now, in looking at the determination of the slope-intercept equation, now we do not have the slope provided. What we have instead are 2 points through which the line is going to pass. And these 2 points we have with the coordinates -4, 8, and -7, -3. So we had to determine the slope. So m is not provided, and so we're going to discover what the value of m is upon the use of the slope formula. And we can go ahead and label what our subscripted x and y values will be. And once again, all ordered pairs are of the form xy. So you have negative 4, 8. We can let this be the first set of x and y terms. And negative 7, negative 3, since that is provided subsequently, we can let this be the second set of x and y values. And thus we have for the slope determination, again, we have y of 2 minus y of 1 all over x of 2 minus x of 1. And for y of 2 minus y of 1, so y of 2 we have at negative 3. Then we have subtraction, and we have y of 1, which is 8. And for x of 2 minus x of 1, so we have x of 2 we have at negative 7. Then we have subtraction, x of 1 we have at negative 4. Negative 3 minus 8, we have negative 11. And then we have negative 7 plus 4. And in the follow through, okay, so we have negative 11, negative 7 plus 4 is negative 3. And now we have the negatives to cancel out. And so we are left with 11/3 for the slope. So we have a non-integer value for the slope. And now for what we have in the next phase, you can choose either of these 2 points in the point slope equation setup. Okay, so for what we have in the case of the point slope setup, okay, again, you can choose either of these 2 points. And tell you what, we'll go with negative 7, negative 3. Again, we had the slope to be determined at 11/3. And now, again, for the point slope setup, we have once again, okay, y minus y of 1 is equal to the slope m times the quantity of x minus x of 1 okay, so we have for, again, we normally say x before we do y, okay, but again, we have the y terms out the front. So we have y minus y of 1. So in this case, having chosen this point, okay, y of 1 we have at negative 3. And the slope m we have at 11/3. And we have times the quantity of x minus negative 7. And here we have y plus 3 is equal to 11/3. Okay, we have times the quantity of x plus 7. And I'll just mention, okay, once again, we have the point slope equation. And looking for the slope intercept. Okay, so once again, we have upon distributing, okay, so you have y plus 3 is equal to 11/3 of x. And 11/3 times 7, so we're going to have a non-integer value with 77/3. And we have upon isolating y, if I take 3 away from both sides, so you have y by itself. and we have is equal to 11/3 of x. For 77/3 minus 3, think of this as 77/3 minus 3 over 1, and 3 over 1 as thirds, and we have 9/3. So 77/3 minus 9/3, this will come out to positive 68/3. So we have for the slope-intercept equation, okay, this will become 11/3 of y is equal to 11/3 of x plus 68/3. Again, just for this format, okay, this is also the point slope, going from the point slope equation, and this we have in the slope intercept equation. And you can do a quick check for both of these points. Okay, so if we have the ordered pair, -4, 8, okay, so y is at 8, and I want the right hand side of the equation to also equal 8, so we have it x at -4. We have 11/3 times -4 is -44/3. -44/3 plus 68/3 is going to be 24/3, which reduces to 8. Also, for this ordered pair, okay, if we have y at -3, I want the right hand side of the equation to also be at -3. So we have plugging in -7 for x, we have 11/3 times -7, which would be -77/3, plus 68/3, and that will become -9/3, which also becomes -3. So this will check out for both of these ordered pairs. All right, now in the crossover, again, to still maintain the development of equations in the XY coordinate system, and again, we had looked at the other day relations between lines, okay, in the context of lines that run parallel as well as perpendicular. And now for what we have from the group in the case of number 23, and again we have for the given slope of a line, okay, we have 3/11, and the problem is asking for the slopes of the parallel and perpendicular lines. Okay, so again we have with a parallel line, okay, again, so a parallel line is going to have the same slope so if the given line has a slope of 3/11, well, we have for the parallel line, okay, the slope is also 3/11. Now for the perpendicular line, okay, you want to have, I'm going to use a little bit of shorthand here, OSR, that's opposite sign reciprocal slope. So for the given line, the slope is 3/11. Now for the perpendicular line, okay, you're going to have the opposite sign reciprocal of 3/11. So we're going from a positive to a negative, and then flipping 3/11. So we're going to come out to -11/3. And again, for perpendicular lines, I'm just going to mention the product of the slope values for perpendicular lines will be -1. So here we have 3/11 times -11/3. So you have -33/33, and the product, okay, we have at -1. All right. And for what we have in the case of number 26, okay, so you have that the slope is equal to -10. And for the parallel line, again, you have the same slope. So we have m is equal to -10. Whereas for the perpendicular line, once again, we're going to have the opposite sign reciprocal of the slope for the given line. So we have going from a negative to a positive and flipping 10. So this will come out to 1/10. Okay, so for the product of the slopes, again, we have -10/10, which reduces to -1. Okay. All right, now, I don't think I had mentioned this problem, but for 32, okay, we have sort of a test to apply. And the question boils down to, are the lines represented by 2x plus 3y equal to 7, and 4x equals -6y plus 2, parallel, perpendicular, or neither. Okay, and so that's going to write upon, okay, first of all, the lines had to be distinct from each other, and we had to determine the slopes. Okay, so if the slopes end up being the same, okay, we're going to have the relation to be parallel. And if we have an opposite sign reciprocal relation between the slopes of these lines, then you're going to have a perpendicular relation. Okay, so we have with the first line represented by 2x plus 3y is equal to 7. If I convert this equation to its slope-intercept form, so we're going to have 3y is equal to -2x plus 7. And we have with division by 3. So we're going to have that y is equal to -2/3 of x plus 7/3. Okay, so in this one, your y-intercept we have at 7/3, and for the slope, we have a -2/3. And for the other line, okay, so you have 4x is equal to -6y plus 2. And if we isolate the y term, now we have the y term situated on the right-hand side of the equation. So if I move the 2 by subtracting, now we have 4x minus 2 is equal to -6y. And if I take care of the coefficient -6 upon dividing the terms by -6, okay, so you got 4 over -6, so that is going to be -2/3. So you have -2/3 of x. And for -2 over -6, okay, so that's going to be a positive, and 2 over 6 reduces to 1/3. And -6y over -6, this is going to go to y. So we have here y is equal to negative 2/3 of x plus 1/3. Okay, so you have different lines here. Okay, you have negative 2/3 of x plus 7/3 for the first, 1/3 for the second. So the first line has a y-intercept at 0, 7/3, and this line has a y-intercept at 0, 1/3. Okay, so the lines are distinct. Now, for the slope, we have negative 2/3. Okay. And so for what we have in this case, all right, so you have negative 2/3 for as the slope for the first line, and negative 2/3 as the slope for the second line. So we had the same slope, and so we're going to have, in consequence, okay, that the lines are going to run parallel. All right, now we have in the next portion, and this is going to tie in the point slope as well as the slope intercept formulas as we cross over in the realm of establishing equations for parallel and perpendicular lines. Now, we have, in the case of 37, okay, and I made this into two-part equation. Now, 37, you're looking for a parallel line. And what I'm going to do here, okay, so you have in 37, okay, so if I make this into a two-part exercise here, and say we have to determine the equation of the line. That is going to run through to 5 and is, we'll say, first of all, we have parallel to the line represented by the equation 2x plus y is equal to 6. Okay, all right, so to establish parallel and perpendicular relations, again, we have to find out just what the slopes are going to be. Okay, so we have in the procedure, okay, now we have for the given line, we have 2x plus y is equal to 6. And if I convert this equation into the slope-intercept form, so we have taking 2x away from both sides, so we have that y is equal to negative 2x plus 6. And so for what we have here, the slope m is equal to negative 2. And we're looking for the parallel line that runs through 2, 5. again for the parallel line. Okay, so the slope is going to be the same. So we have the slope at -2. And again, we have the parallel line runs through 2, 5. And so we have for the point slope formula setup. Again, so we have y minus y01 is equal to the slope m times the quantity of x minus x01 for y minus y01. Okay, so we have y minus 5 is equal to, and for m, okay, we have at -2. And we have times the quantity of x minus 2. So this is our point slope formula, and looking for the slope intercept. Okay, so you have y minus 5 is equal to -2x plus 4. Then we have upon adding 5 to both ends. So we had that y is equal to -2x plus 9. Okay, so we had the slope also at -2. And for 2, 5, okay, so you have y at 5. And I want -2x plus 9 to also be at 5. So we have with x at 2, we have -2 times 2 is -4. -4 plus 9 comes out to 5. And now, let's say you're just throwing this in. If I'm looking for the slope-intercept equation of the line that is going to be perpendicular to the line represented by the equation 2x plus y is equal to 6. And I'm going to copy down the information for the given line as our backdrop. Okay, so you got the given line. Okay, the slope once again is -2. Now for the perpendicular line, okay, now remember, okay, now perpendicular lines will have slopes that are opposite sign reciprocals. So the slope of the given line was at -2. Now for the perpendicular, we have an opposite sign reciprocal. So you have going from a negative to a positive, and flipping the 2, or 2/1, we're going to have it 1/2. And once again, the point through which the line passes, okay, we have it 2, 5. Again, just a reminder, okay, so for perpendicular lines, yeah, the product of the slopes, yeah, -2 times 1/2, which we have at -2 halves, and again the product comes out to -1. And for what we have in the point slope equation setup, again, so you have y minus y01 is equal to the slope m times the quantity of x minus x01. And for y minus y01, okay, so you have y minus 5. And we have equal to 1/2 times the quantity of x minus 2. Okay, so this is our point slope equation, and for the slope intercept, if I look at, once again, distributing 1/2 over the quantity of x minus 2, so we have 1/2 of x minus 1, and once again adding 5 to both sides, we're going to have that y is equal to 1/2 of x plus 4. Okay, so you have y at 5, and I want the right hand side once again to be at 5. So here we have 1/2 of x is 1/2 of 2, which is 1, and 1 plus 4 is equal to 5. So we do have consistency throughout. Now, for what we have in the case of number 39, okay, now this problem was asking for the equation of the line that runs perpendicular to the given line. If I can make this into a little bit of a two-part here. Okay, so if I determine the equation of the line, that runs through 6, negative 4, and is going to be, and we have for, we'll just call this part A, and is perpendicular to the line represented by the equation x minus 5y is equal to 1. Okay. And I know that in Alex, okay, you might be asking for like slopes of or equations of lines that are parallel and then perpendicular. I think there's like maybe two problems. The first, which will ask for the parallel part and then the perpendicular part, and the next item has the sequencing reversed, where you're looking at the perpendicular followed by the parallel. Now, for what we have in the case of the given line, so we have x minus 5y is equal to 1. And if I convert what I have in this equation to the slope-intercept equivalent, so if I take x away from both sides, so I have negative 5y is equal to negative x plus 1. And upon dividing by negative 5, okay, so we're going to have y is going to be equal to, and you have negative x over negative 5, so this will be a positive. So you have 1/5 of x, and 1 over negative 5, so you have a negative 1/5. So we have the slope for the given line to be at 1/5. Now, for what we have in the case of the perpendicular, Again, perpendicular lines will have additive inverse slope values. Okay, so for the first line we have the slope at 1/5, and you have opposite sign reciprocal values, not additive inverse, but opposite sign reciprocal values. So for the first line we have the slope m equal to 1/5. For the perpendicular we have the slope m equal to -5. Okay. So again you have like 1/5 times -5 is equal to -1. And again, the point through which the perpendicular line passes is 6, -4. And using the point slope formula setup, and with the tools that we have for substituting, we have for y minus y01, that's going to be y minus -4. And for the slope m, okay, so we have -5. And we have times the quantity of x minus x01. So again, we have x01 is going to be at 6. Left hand side, okay, we have y plus 4. Again, we have -5 times the quantity of x minus 6. So again, this is the point slope equation, and converting in terms of the slope intercept. So we're going to have y plus 4. Right hand side we have -5x plus 30. And we have taking 4 away from both sides, and it is going to follow that y is equal to -5x plus 26. And you can check, okay, so you had the slope at -5, and with 6, -4 for the x and y values respectively. Left hand side of the equation we have -4, and with x at 6, -5 times 6 is -30. -30 plus 26 is also -4. -4 is equal to -4, so we have consistency. Okay, and we have, just throwing in this extra part here, if I have parallel to the line represented by the equation x minus 5y is equal to 1, again just using the information for the given line, okay. So again we have the slope is going to be at 1/5. And for the parallel line, again, parallel lines will have the same slope, so this time m is equal to 1/5. And again, we have the point through which the parallel line is going to pass, just like what was prescribed for the perpendicular. We have at 6, -4. So we have in the point slope formula setup, so yeah, y minus y01 is equal to the slope m times the quantity of x minus x01, and then we have filling in. So for y minus y01 we have y minus -4, and the slope m we have at 1/5. And we have times the quantity of x minus 6. So y minus negative 4 becomes y plus 4 is equal to 1/5 times the quantity of x minus 6. And we have upon distributing on the right, so we have y plus 4 is equal to 1/5 of x minus 6/5. And we have upon subtracting 4 on both sides, so we have on the left we have y by itself, and have equal to 1/5 of x. Now for the difference that we have with negative 6/5 minus 4, so we have negative 6/5 minus 4, we have minus 4 over 1, and then raising in terms of the denominator 5. So this will become negative 20/5, and negative 6 and negative 20 will become negative 26. And for the difference of fractions, we have minus 26/5. So we have here y is equal to 1/5 of x minus 26/5. Okay, so you have the slope at 1/5. And again, you can test out what we have here. So y again is at negative 4. And we have with x at 6, we have 1/5 of 6 is going to be 6/5. Take away 26/5, so you have negative 20/5, and negative 20 over 5 also reduces to minus 4. So this will be the equation of the parallel line in the slope-intercept form with the given information. And I'll tell you what, just for the next few moments, tell you what, let's see what we get for the slope-intercept equation. Of the line that runs through 410 and is going to be, say first of all, we'll say parallel to 2x minus y is equal to 7. And also going through the same point, let's also determine the slope-intercept equation of the line that is going to be perpendicular to 2x minus 7. Okay. And just to specify further, got a little bit ahead of myself. No, you know what? Long week. See, we have parallel to 2x minus y is equal to 7. And we have also perpendicular to 2x minus y is equal to 7. So just for the next few moments, let's see what we get for the slope-intercept equations of these lines. Okay, so we're looking for the slope-intercept equations of the concerned parallel and perpendicular lines, and just kind of a setup here. And we have for the given line, okay, we have with 2x minus y is equal to 7, and And if I convert what I have here to its slope-intercept equation equivalent, okay, so we have starting out with 2x minus y is equal to 7. And if I get the y term by itself, so we have, upon subtracting 2x on both sides, so we have negative y is equal to negative 2x plus 7. And I can either multiply or divide on both sides of the equation by negative 1. Okay. In other words, what was negative becomes positive, and the other way around. Okay, so we had that y is going to be equal to 2x minus 7. So we have here that the slope is equal to 2. And just looking at the simultaneous setups. Okay, now for the parallel line, again, parallel lines are going to have the same slope. Okay, so we had the slope m is equal to 2, and again we have to pass through the point 410. And we can go ahead and point out, okay, what the setup will be for the perpendicular. Okay, and again, perpendicular lines will have opposite sign, reciprocal, valued slopes. Okay, so for the perpendicular, now while the parallel has the same slope at 2, again, the opposite sign reciprocal of 2 is going to be a minus 1/2. And the perpendicular line, just like the parallel, is also going to pass through 410. And so we have for the parallel, okay, so utilizing once again the point slope formula. So we have a y minus y01, so we're going to have y minus 10. And we have equal to 2 times the quantity of x minus 4. So this is our point slope equation for the parallel. And in terms of following through to get to the slope intercept equation, so we have 2 times the quantity of x minus 4. So this will be 2x minus 8. And getting the y term by itself, if I add 10 to both sides, so we're going to have that y is equal to 2x plus 2. Again, we have the slope at 2, and for y is equal to 2x plus 2, so y is at 10 for this point, and I want the right hand side of the equation to also be at 10, so 2 times x, which we have at 4, is going to be 8. 8 plus 2 is equal to 10. Okay, now for the perpendicular line. Again, so just going through the point slope setup. So for y minus y01, okay, so that's going to be y minus 10. And we have for the slope m, so we have negative 1/2 times the quantity, so we have x minus 4. Okay, so again we have same x1, y1 values, and again we had the slope this time at negative 1/2 as opposed to 2, which we had for the parallel. And so this is our point slope equation. Now for the slope intercept, if I distribute negative 1/2 over the quantity of x minus 4, I'm going to have the statement that y minus 10 is equal to negative 1/2 of x plus 2. And again, getting y by itself upon adding 10 to both sides. So we're going to have y is equal to negative 1/2 of x plus 2 plus 10, so we have negative 1/2 of x plus 12. And so for what we have here, testing out, so you have with x at 4, negative 1/2 times 4 is negative 2. Negative 2 plus 12 is 10. In this case, that is also the value for y. So we have consistency throughout. Now, there's going to be sort of an analytical part that we have regarding the concept of slope. But what I'm going to do before I get to that, there is an item that will be what we have with what are regarded as piecewise defined functions. And in terms of graphing, okay, you might have separation of the function into, say, separate line segments. And now for piecewise defined functions, okay, and just for piecewise defined functions, like there could be like a real life example where you can have like if somebody's doing their taxes and you got your separate tax brackets. They're kind of like if somebody's income is greater than a certain lower limit, and then you have up to and including the upper limit, then say you have belonging to the 10% bracket, and then the next phase you have going into the 12% bracket, and then you have so on and so forth. So you have like the separation by tax bracket. So that could be a case of a piecewise defined function. Now let's say that if we have, just in terms of the use of the functional notation, and say if we have given, and we'll say you have like y is equal to f of x is equal to, and instead of having f of x given as one statement in the independent variable x, we have just like separations here. Okay, so you have if we have given f of x is equal to, and we'll say 2x plus 5. Say if we have that x is less than negative 2. So anything less than negative 2, you're going to apply this part of the function. And let's say that we can also have that f of x is equal to 3x squared. If we have a different set of x values, and we'll say we have negative 2 is less than or equal to x is less than 5. And we say that for any other set of values x, we say that y is equal to f of x is equal to 3x plus 4. if we have it such that x is greater than or equal to 5. Okay. So you're given this set of values, and let's say that we're to determine what y or f of x is going to be whenever we can say we have x at 20, as well as x at negative 40, as well as a function whenever x is set to 4. And we can say that we have rounding out the rest. Okay, we have whenever x is at negative 2, and also whenever x is at 5. Okay. So we have looking at what we have for this piecewise defined function. Okay, say we have starting out with 20. Okay, so your x value we have at 20. Okay, and so in terms of which of these inequality statements will describe 20? Well, if x is 20, well, 20 cannot be less than negative 2. And also 20 is not going to fall between negative 2 and 5. Now, to say that 20 is greater than or equal to 5, that is going to be true. So it's going to belong to the last statement here. So it is true that 20 is greater than or equal to 5, because we do have that 20 is greater than 5. So that part makes it true. And in terms of what to do with 20, okay, so for those values of x greater than or equal to 5, we're going to apply 3 times the input, followed by the addition of 4. So yeah, 3 times 20 is 60. And we have 60 plus 4, which will come out to 64. Again, why did I use 3 times 20 plus 4? And it's because of the input 20. And that fit in with the last inequality, so you use this part of the function. Now for f of negative 40. Okay, now negative 40 is definitely less than negative 2. So in terms of what to do with negative 40, okay, so we have 2x plus 5. So we're going to have 2 times negative 40 plus 5. Two times minus 40, we have at negative 80. And then we have, in turn, we have negative 80 plus 5, which we will have at negative 75. In the case of f of 4, okay, in terms of where 4 belongs among the x values, okay, now 4 is not less than negative 2. Now, we have for the compound inequality, now we do have that negative 2 is less than or equal to 4, in turn is less than 5. Okay, so first half of the compound inequality, so you do have the less than for the negative 2 is less than or equal to portion to be true. And with x at 4, 4 in turn is less than 5. And so we're going to use the 3x squared part of f of x. So for 3x squared, we're going to have 3 times the square of 4. 4 squared is going to be at 16. And 3 times 16 comes out to 48. All right. Now in the last two cases for f of negative 2 and f of 5, notice that both negative 2 and 5 are specified values among the inequalities. So for where negative 2 goes, now first statement, if I envision x at negative 2, now to say negative 2 is less than negative 2, that's a false statement. Now we have with negative 2 again at x, if I have negative 2 is less than or equal to x. Now negative 2 cannot be less than itself, but it is equal to itself. And we have in turn negative 2 is less than 5, and that is going to be true. So we're going to have, once again, like what we had with 4 just a moment ago, we're going to have the compound inequality to apply. Again, so this compound inequality, that is made true with the inclusion of the equal sign. And so once again, just like with 4, negative 2 is going to undergo the 3x squared treatment. So we will have 3 times the square of negative 2. And the square of negative 2 is going to be at 4. And 3 times 4 is equal to 12. And as for what we have for f of 5, okay, so you have among the inequalities to which 5 is going to be applied. Okay, so 5 is not less than negative 2. And for the compound inequality, now negative 2 is less than or equal to 5. However, 5 in turn cannot be less than itself. And as for the last inequality, now 5 is not greater than itself, but it is equal to itself. So we have 5 is greater than or equal to 5. So we'll use the x is greater than or equal to 5. Okay, to describe 5. Okay, so 5 is equal to itself, and then 5 is going to undergo the 3x plus 4 treatment. And so we have 3x plus 4 becomes 3 times 5, which is 15 plus 4. And so we have with the final output, okay, we end up at 19.